exercise a03 is going to be extremely similar to exercise a02. The purpose, once again, is to add some feature to our abstract data type to make it behave like a queue, but while we're using a maximum of code. So we're going to have QE.h, QE.c, test QE, which are going to be really close to the stacky versions, and we're going to add an enqueue and a dequeue function to our repertoire of functions for the abstract data type that we are building. The enqueue function is going to add pretty much value to the front of the list. The dequeue function is going to remove value from the end of the list. Okay, so the front of the linked list is going to represent the front of our, or the end of our queue, and the back is going to represent pretty much where we remove data from the front of our queue. So we're going to go back here to our code. I started this project by making a copy of the linky and stacky files and copying also the stacky files into their QE counterparts. So you see here the QE test file which are modified, okay, to call the enqueuing and dequeuing function instead of using the stacking push and pop function. In addition to this file, we have here we have the stacky.h. We have the QE.h, which is going to be really similar to the stacky.h as you're going to be seeing really soon. Let me click again here. Let's keep this open, that will go a little faster. The QE.h file is going to include also linky.h, give the prototype of our two new functions. QE.c is going to implement them, and so far I've been just making a copy of what we had with stacky. So we are going to look into this right now, and we are going to modify these functions. So as for the stack, we need to establish our convention, okay? The queue is going to be our linked list. Well, let's make up the convention that we are going to unqueue things at the end of our queue and dequeue them from the top. So the first element of data that comes into the queue is going to be actually the first one to come out, which is the opposite of the stack. In the stack data structure, the last element in is the first out. Last in, first out, LIFO. In a queue, the first in is the first out, FIFO. You unqueue an element, and then you keep unqueuing over element behind it, and then you dequeue at the front of your line. So we are going to unqueue. Let's try to make this easy with respect to the visualization that we have in our test. So when we display our list, we display it first element to the left, last element to the right. Well, let's visualize this as a queue of people waiting in line. We are going to unqueue to the left, dequeue to the right. So let's make it so that we unqueue at the front of the list and we dequeue at the end of the linked list. Unqueuing at the front is going to be easy. Gcell add front list new. Dequeuing at the end will involve that first we can find the last element of the list. Once we find the last element of the list, we are going to actually take its value, return its value, and before to return its value, we are going to deallocate this last element of the list. So there are several things that we need to do here. We are going to, at some point, store the value of that element. So let's declare an integer value variable, which is going to allow us to do that. Then we need to move forward to that list until we find the last element. We could do it recursively, but we would have to actually, it would be like probably easier to do it with an iterative manner. Otherwise, in the recursive version, we would have to have a little backend function here that would do the search. So let's do it in one shot with only one function here. Tcell star p equal star list. We are used to that. Okay. While let's locate the last element. While p arrow next different than null. I keep advancing. P equal P arrow next. Okay, let me take a look at that. Well, if I'm going to go For dereferencing pointers here, I need to make sure that this is safe to do so. If list equal null, well, what do? I'm trying to dequeue something. There's a problem. Well, I cannot return a value that is meaningful. If I return any int, it's going to be interpreted as the value that was dequeued. So I'm going to do what I did with the stack. Okay, I'm going to display error cannot dequeue, and between parentheses null pointer, and that should be enough information. Exit -1, close the curly brace, and handle my first error situation. Let me minimize this. Okay, now on to the next one. What happens if my queue data structure is empty? Well, the same thing is going to happen. So I'm going to make a cut and paste here. There we go. The error this time will be not that the pointer is null, but I'm just going to put the keyword empty between parentheses to help whoever gets this error realize what is really going on. Empty. There we go. Save. Now, once I get that out of the way, I can safely dereference here star list. I can enter my loop. If p row next is different than null, keep advancing. Then once I am on the last element, val equal p row data. This is going to be the data of the last element. Now I should be removing the last element. Well, no need to re-implement what has been already done elsewhere. Okay. tcell del tail list. And then return val. Saving this file. Let's go back to the terminal. We are going to compile, well, what do we need? We need linky.c, we need qe.c, and we need our test for the main. Compilation, line 23, qe.c, we have an error, val undeclared. I must have used val and value. So let's go to the file qe.c, and let's take a look at line 23 real quick. Val instead of value. There we go. So I'm going to replace here by value space, save. Return val here is going to be exactly the same issue. So I'm going now line 27, and I'm going to return value. Save again, go to my terminal. Let's compile again. Compiles fine. Let's try to execute it. And queuing is going to add to the left. Okay, imagine a queue of people waiting in line. So my initial queue contains only element 0, then 1, 2, 3 are added to the left. Dequeuing is going to remove element 0, the first one that was in my queue, then element 1, then 2, and I should add like one more call here to make sure there is nothing that was allocated that was not deallocated, but pretty much you can see here that the logic of the queue has been implementing by adding those two little functions.